Hello friends, today we are going to write a program for hexadecimal to ASCII code conversion. Uh, we already know that the keyboard available in the market have these characters 0, 1, 2, 3, 5, 6, 7, 8, colon, semicolon, greater than, equal to, question mark, at the rate. And apart from these, there are various other characters or symbols are there in the keyboard, and corresponding to those characters or those symbols, a code is given to that particular symbol or a character. Okay, so for example, for 0 it is given 30H. This is a ASCII code, American Standard Code for Information Interchange. So it is decided that if we are pressing a key 0 on the keyboard, then we are sending a value 30H to the microprocessor. Alright, so similarly for 1 it is 31H, and up to 9 it follows the same pattern, 39H. And our hexadecimal number starts from 0, and from 0 to it goes to 9, and then from A to F. These characters comes under hexadecimal number. That's why we will be considering only characters 0 to 9, and after that from A to F. We will talk about only these characters and their codes. We will not talk about rest of the characters, like these are the characters, and after F there will be GHIJKL, and before 0 is again there are some characters there. So we are not interested in the ASCII code of those symbols or characters. We are interested only in the ASCII code of 0 to 9 and A to F, because these numbers correspond to hexadecimal numbers. Okay, so from here we can see easily that if you have got a number in between 0 to 9, then simply you have to add 30 to these numbers. Okay, so if you are adding 30, then you are getting 30H. For 0 the code is 30H, for 1 code is 31H, similarly for 9 code is 39H. That means in order to get the ASCII code of these numbers, simply we will add 30 to them. Alright, and similarly in order to get the ASCII code of these numbers, we will have to add 37 here. Well, why 37? Because these are the 7 characters, 1, 2, 3, 4, 5, 6, 7. These are introduced in between 9 and A. That's why we will have to take care for that. So here we will have to add 37H. For example, we are going to add 37H to the accumulator. So both of these are hexadecimal numbers. So A corresponds to 10, and 10 plus 7 is 17 in decimal, and in hexadecimal it is called 1. That's why 1 will be here and a carry 1 will be here. So 3 plus 1 is 4, and 4 is same in decimal and hexadecimal, so it will be 41H. And here it is for A, the code is 41H. That means in order to get the code for A to F, simply we will have to add 37 in the given number. Alright, so we have got the funda that first of all we will have to check whether the number given, assume number is X, because we don't know, user will provide this number. So number may be equal to, number may be in between this range, or it may be in between this range. Okay, so that means first of all we will have to check that this number falls under which category. It comes under this case or in the second case. So in order to check that, we are going to compare the given number. Alright, so if we compare the given number X with A, I am saying assume there is a number X, it may be any number. Okay, so if given number X we are going to compare to A, then there will be cases. Okay, X may be less than A and X may be greater than A. There will be two cases, or X may be equal to A. Okay, so for the case when X will be less than A, so for example assume X is 8 here for this particular case. So obviously 8 will be less than A, and if X is less than A, that means we will get a carry here. Alright, so carry will be 1 for this case when number provided is less than a. And for second case, the number given is if greater than or equal to a. For the both cases, carry will be 0. That means in order to get the conclusion that whether number falls under this category or this category, we will have to check for carry flag. Okay, so there are two conditions. One is for carry is equal to 1 and second is for carry is equal to 0. So carry is equal to 1 corresponds to instruction JC and carry is equal to 0 corresponds to instruction JNC. That means now we may use any one of these two instructions. So which instruction will we use? So I have told you in my earlier lectures that is simply follow the rule that use that particular instruction for which we will have lesser number of steps to do. Lesser number of steps, or you can say lesser number of instructions to write. This is my funda. Okay, so there are two possibilities. You may choose carry is equal to 1, you may choose carry is equal to 0, and shortcut method is simply use that particular instruction for which there is lesser number of steps to do, or there is lesser number of instructions to write. Okay, so let's see for both the cases. So we have already told that if you are getting carry is equal to 1, that means number will comes under this category, and in this category simply you have to add 30h to the given number. Alright, and that will be your answer. But for this case, if you are getting a carry is equal to 0, that is if the number falls under this condition, then you have to add 37 to x, and you may think as that this is like adding 30 and then adding 7h. Okay, so that means you will have to first of all add 30 and then you will have to add 7h in order to get a total addition of 37h. That means from my funda we will be using this thing, because here is the lesser number of steps to do. Only we have to add 30, but here in second case we have to add 30 and then after we have to add 7. So from here I think we should use JC in our program, because for JC we have to simply add 30h and for JNC we have to add 30 plus 7h. So let us start write the program. So I am assuming that user will give number in between 00 to 0fh. Okay, so user is giving number in between 00 to 0fh, because if user will give a number of 2 digit like 3fh and 13h, in that case we will have to find out these numbers. That means the number will be present only at first place. So I will discuss that in my different classes. That is masking of these upper nibbles and lower nibbles. I will discuss in my other classes, other videos. So here I am assuming that user will provide this number. Okay, so we will have to take an address where user will write this number. So I am assuming that user will write this number, any one of these numbers, at 2050h location, and we are going to write answer, that means result, at 2051h location. Okay, so let's start writing the program. So first of all we will have to get the number present at 2050h in the accumulator. Alright, so simply I am going to write LDA 2050h. Remember, this instruction simply gets the value present at memory location 2050h into the accumulator. So accumulator will have the number. Alright, and next step is we have to compare that number with the value 0ah, as I have told you here, that we will compare the number with a. This is 0ah, the value. Okay, not the accumulator. So for comparing an immediate value, we have an instruction CPI 0AH. This instruction performs a comparison in between accumulator and 0AH. Okay, and according to that, this instruction will set or reset the flags of flag register. Here we are concerned with only carry flag. So as I told you that we will be checking for carry is equal to 1. So that's why I will use here, after comparison I am going to take decision JC, and after getting a carry I am going to jump at some specific memory location, and I am specifying that memory location here FWD. See, I have left some space here because I will write here instruction for the case carry is equal to 0. Alright, so remember that we had to do, if we are getting a carry is equal to 1, then simply we have to add 30 to the original number. So here in the case we have got the carry and we have jumped to this location. So now the thing is that I have to add only 30H to the number. So assume that at place 2050H number was 3. Assume. So after this instruction the content of accumulator will be 3. 3 will be compared with 0AH and obviously we will get a carry, and microprocessor will jump to this location, this label, and ADI is 30H. This will perform content of accumulator plus 30H and result will be stored in accumulator. So 3, remember the number was 03H at this location, so 3 plus 30 we will get 33, and that was the code of 3. So simply we have got the answer, and now we will store that answer at the memory location 2051H, and after that halt. Well, remember that we have not written any instruction for JC carry is equal to 0. So what will happen if the number given here is, assume it is B, assume. So simply at this stage accumulator will have number 0B H. That number will be compared with 0AH, and obviously as A is greater than B is greater than 0AH, so no carry will be generated, and in this case carry will be 0. And if carry will be 0, that means microprocessor will not execute this instruction, okay, because it will find the condition false. So the instruction written next to this will be running. Okay, so next to it what we are going to write, actually we can see that after this instruction already 30 is added to the accumulator. So the thing is, remaining thing is that we have to only add 07H at this stage. So simply we are going to add ADI 07H. So let's see, content was B in accumulator, it was compared with A and we did not get any carry. So 7 was added to B and then 30 was added to B. So the content will be this time 42H, and that will be stored at location 2051H. Well, this was very simple program. Okay, I hope it was very easy. Well, thanks for watching, and do subscribe to my channel to get my next program. Thank you.